Hi, I'm David, and in today's diagnostic module, we're going to be looking at accelerator pedal position sensors, their circuits, and how we diagnose them. We'll look at some common DTCs set by this sensor, and we'll go through each one individually to see how we diagnose it. We'll be doing it on the diagram to show you the procedure, and then we'll move over to the vehicle to show you the process. Here we see a diagram of the complete electronic throttle control circuit. We have a TPS or throttle position sensor, and we have an APP or accelerator pedal position sensor. The accelerator pedal position sensor consists of APP1 and APP2. Let's have a closer look at one of these sensors. You can see from this overlay that the sensor is simply a variable resistor. One side is connected to a voltage and the other side connected to a ground. The wiper, which swings between the minimum and maximum, goes to either a pull-up or a pull-down circuit. Both APP1 and APP2 have a variable resistor as their sensor. Let's have a look at APP1. We have a reference voltage here labelled V1. Always check your schematic to make sure that you have the correct voltages for your particular circuit. It's a reference voltage, so that means it should be exact. Close enough is not good enough in these instances. We also have a ground. Most of the time that comes from the module, but it can come from the vehicle itself. And we have a signal wire that goes, in this case, to a pull-down circuit. It could also go to a pull-up circuit, and it really doesn't make much difference. So that's the construction of the circuit. So let's have a look at the DTCs. We could get a P1125, and that's a fairly generic sort of DTC. It indicates that we have an accelerator pedal position problem. It doesn't specify what the problem is. Not all vehicles set this DTC, but if it does set one, you have to go through the whole testing that we're going through in a moment. DTC 2122, which is accelerator pedal position sensor 1 circuit low voltage, that's indicating that we have 0 volts on our signal wire. Our signal wire will normally vary from a minimum to a maximum. It will very rarely go to 0 volts or very rarely go up to the maximum voltage. That's so we can set DTCs. So we know we've got 0 volts on that wire. How do we test to make sure where the fault is? We disconnect the sensor first of all. We now check to see if we have 0 volts on pin C. With it connected to the ECM, we should have 0 volts there because it's a pull-down circuit. Next, we disconnect the engine control module. This will eliminate the ground from the pull-down circuit. If there is still a 0 volts or a ground on pin C, that means we have a short to ground on the signal wire. If we don't have a short to ground on that signal wire, the most likely cause is the accelerator pedal position sensor. We can also get a P2123 accelerator pedal position sensor high voltage. This time it's indicating that we have above the maximum voltage on our signal wire. Same process, disconnect the accelerator pedal position sensor and check to see what voltage we have on that wire. We should have 0 volts. If we have anything other than 0 volts, that means we have a short to voltage on that wire, and that's what our problem will be, so we have to diagnose it. If we have 0 volts on there, the most likely cause, again, is the pedal position sensor. P2127, accelerator pedal position sensor 2 circuit low voltage, we diagnose exactly the same as we would do a P2122, except this time we use APP2 instead of APP1. The same goes for P2128, accelerator pedal position sensor 2 circuit high voltage. We do exactly the same test as we would have done for a P2123, but this time on APP2. The final DTC we're going to have a look at is P2138, accelerator pedal position sensor 1 and 2 not plausible. What that's indicating is that the signals coming in from APP1 and APP2 are not corresponding as they should do. The engine control module has sensed that there is a fault or there's an abnormality in one of those signals. So how do we test this? This time we've got to look at all the pins, not just the signal wire. So we disconnect the sensor and we look for V1 on pin A. Remember, it's a reference voltage, so it has to be exact. If it's above the reference voltage, that's our fault. We've got to short the voltage somewhere. If it's 0 volts, that's our fault. We have no voltage on there. Open circuit is a possible cause of that. Moving on to pin B, we should see a ground or 0 volts on that pin. If we don't see a ground, look for a voltage. Again, it could be a short to voltage that's causing that problem. If there's no short to voltage and there's no ground, again, it's probably an open circuit in the wiring. We've already seen how to test our signal wire, so we'd repeat that process again. We then move on to APP2, and we repeat the tests. We check for our voltage, we check for our ground, and we check for our signal wire. If all of those are correct, it must be the accelerator pedal position sensor that's at fault. Let's go onto the vehicle and have a look at some of these tests. We're going to be having a look at APP1 on this vehicle. It uses a 5 volt reference, but always remember to check the reference voltage on your vehicle. It also has a ground and a signal circuit. The signal wire normally goes between 0.2 of a volt to about 2.7. This is not necessary to know for the testing of this circuit. Let's have a look at the 5 volt reference voltage. I've got my multimeter hooked up between the connector and pin 4 on the DLC, and we should see 5 volts. And as you can see, we've got 5 volts. So that means that that wire is correct. I'll now move my multimeter connections from the 5 volt reference to the 0 volts and from pin 4 to pin 16. With my connections between the ground or low reference and pin 16, which is B+, we should see 12 volts on the meter. And as you can see, we've got 12 volts on our meter. So that means that circuit is correct. So we'll now move the pin across to the signal circuit. Because this is a pull-down circuit, there's no need to move the other multimeter lead. We're looking for 12 volts because we're connected between B+ and a pull-down circuit. Let's have a look at the meter and see what our reading is. There we have 12 volts or battery voltage. That means that all the wires have the correct voltage. So the most likely cause for this fault is a faulty accelerator pedal position sensor. And that was a sensor fault. Let's have a look at some circuit faults. I've got my multimeter hooked back up to my 5 volt reference circuit, and we should see 5 volts on the multimeter. But as you can see, we've got 0 volts. So the next thing we need to test for is a short to ground. I've moved the multimeter lead from pin 4 to pin 16. This time we're looking for a short to ground. If we see 12 volts on our meter, that would indicate we have a short to ground. So let's have a look. And sure enough, we've got battery voltage there or 12 volts. So we've got a short to ground on our 5 volt reference wire. That's our fault. If there was no short to ground showing and there is no 5 volts, the problem is we have an open circuit on our 5 volt reference wire. Let's have a look at the ground circuit. I've got my leads connected up to the ground circuit and I should see 12 volts or battery voltage. But the meter's showing 0 volts. That indicates a problem. And it could be either an open circuit or a short to voltage. Let's have a look at the short to voltage first. To do this, all I need to do is move the lead on the DLC. With the leads swapped over, we're now looking for a voltage on our earth circuit. If we have a look at our meter, you can see that I've got 5 volts. So I've got a short to voltage. If there was no short to voltage and there was no ground, I've got an open on my earth circuit. I've got my leads connected to the signal circuit. We should see 12 volts because we're connected to a pull-down circuit and pin 16 on the DLC. But as you can see from the meter, I've got 0 volts. That would indicate that either I have a short to voltage or an open circuit. We'd test those exactly the same as we did for our ground circuit or our low reference circuit. And remember that if all your voltages are correct on each pin, the most likely cause is the accelerator pedal position sensor itself. If we have an incorrect voltage, that's our fault. And that's accelerator pedal position sensors, their circuits and how we diagnose them. We've looked at several DTCs, the most common ones. and we've looked at how we go through the diagnosis process. We've shown you how to determine whether it's a sensor or the wiring itself. Sensor faults can come in a variety of forms. If it's a contact type sensor, it might simply be the age of the vehicle. The accelerator pedal has been used quite a lot, and that's damaged the circuit. And that's one of the reasons we've gone over to a non-contact type sensor. These sensors are far more reliable, but regardless of which type of sensor is fitted to the vehicle, they're still tested all the same. If all the voltages are correct, it's probably the sensor. If one of the voltages is incorrect, that's our fault. And don't get yourself all tangled up. If you're looking for 5 volts and you see 4.5 volts, don't wonder why it's 4.5, just accept the fact that it's not 5 and go looking for the fault. This will help your diagnosis immensely. I hope you found this module informative and that it aids you in your diagnosis. But always remember, training is your key to success. Bye for now.